Good morning to all of you. My name is Vishal Jayas. I am assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. Here my topic is asynchronous data transfer, that is in the subject of computer organization and architecture. This subject is in BTech CSE second year, and if we talk about asynchronous data transfer, first we know the data transfer in types of data transfer in computer organization and architecture subject. Let's suppose we have basically we have three units. First one is CPU. Let's suppose take one CPU, that is called central processing unit, and one unit is called memory unit. This is memory, and another is called I/O devices. I/O means input output devices. Basically, CPU communicate with memory and I/O devices through buses. We have basically three buses used in computer organization architecture, and that's our system bus. And in system bus, we classify the buses in the three types. That means data bus, control bus, and address bus. If CPU wants to communicate with the memory, there is one bus called control bus, and another bus is called address bus, and third bus is the bidirectional bus, that is called data bus. If CPU wants to transfer data between CPU, memory, and CPU, then CPU use three buses. First one is control bus, second one is address bus, and third one is data bus. Similarly, if CPU wants to communicate with I/O devices, then CPU use the three buses for the I/O devices. Means control bus, address bus, and data bus. Basically, in the CPU and I/O devices, there are some registers are used. Let's suppose we have one register and we have another register. This register is called as MAR, means memory address register, and another register is called MDR, that means memory data register. Basically, CPU uses for communication, basically two registers are used, that is one for memory address register and another is memory data register. And I/O devices, let's suppose we have n I/O devices, then each I/O devices have at least one register in it, at least one register for storing the temporary data. We can see in the example of printer, if we print the command and after that we cross the file, then we can see that the print command which have earlier I give, then printer take the printout of that whole the document, because that from the print command the whole data is gone into the registers of the I/O devices. So in I/O devices, we use registers, in CPU we use registers, and basically these three lines are used to communicate with the CPU and iBio devices and CPU to memory. This is the communication between CPU, memory and iBio devices. From this diagram we can also see that we different types of communication between CPU, memory and iBio. If we talk about, our topic is asynchronous data transfer. Asynchronous data transfer means the we have two entities, one is sender entity and another is receiver entity. We have two entities and sender send the data to the receiver and receiver acknowledge to the sender. If we can say that this is a CPU and this is a iBio devices, and in previous diagram we see that the CPU has the registers and iBio devices also has the registers. Let's suppose CPU has a one register and iBio devices has the one register. Then if CPU registers and iBio registers have the common clock, let's suppose there is a common clock that is used by iBio devices registers and CPU register. If both the devices, means sender or receiver, or we can say that CPU and iBio use the same clock, then we can say that this is called the synchronous data transfer. And if we can say that there is one different clock for CPU and another different clock for iBio registers, then in this scenario the CPU, in this scenario we can see that there are two different clock that are used in CPU and another is used in the iBio devices. We can see that there are two different clocks. Then for the synchronization purpose we need some another control signal like stop and handshaking. Then if we talk about asynchronous data transfer, then this scenario is called the asynchronous data transfer. In this scenario we can see that we have one clock for CPU and another clock for iBio devices. This scenario is basically called asynchronous data transfer. So we can we discuss the concept of, first we discuss the concept of data transfer in computer organization and architecture, and see that basically there are two types of communication. First in between CPU and memory and another in between CPU and iBio devices. And for this communication basically we uses the three control lines, three buses. First is control bus, address bus and data bus. Here we can say that if two units such as CPU and iBio interface, first unit is CPU and another unit is interface unit, are designed independently of each other, if the register in the interface share a common clock with the CPU register, the transfer between the two units is said to be synchronous. In most cases, the internal timing in each unit is independent from the other in that each unit uses its own private clock for internal registers. In that case, the two units are said to be asynchronous to each other, and this approach is widely used in most computer systems. And asynchronous data transfer between two independent units requires that the control signals to be transmitted between the communicating units to indicate the time at which data is being transmitted. A stop pulse supplied by one of the units to indicate to the other unit when the transfer has to occur. And another method commonly used in to accompany each data items being transferred with control signals that indicate the presence of data in the bus. The unit receiving the data items responds with another control signals to acknowledge receipt of the data. This type of agreement between two independent units is referred to as handshaking. Basically, for asynchronous data transfer, we have two methods for asynchronous data transfer. First one is stroke control method and second one is handshaking method. So, we discussed the first method, that is a stroke control method. In stroke control method, we can say that the strobe may be activated by either the source or the destination unit. The data bus source unit to the destination unit, and typically the bus has multiple lines to transfer an entire byte or word. The strobe is a single line that informs the destination unit when a valid data word is available in the bus. So, we can say that in this diagram, there is a two units. First one is source unit and another unit is destination unit, and we uses the data bus in the direction from the source to destination, and another uses the control line that is called strobe control signal, that is in the direction of source to destination. This is the block diagram for source initiated. Basically, this is the case of source initiated. Source initiated. Why source initiated? Because in this case the source activates the strobe pulse. Basically, strobe pulse is like control signal that is activated by the source. So, we can say that this method is called the source initiated method. And source initiated the strobe pulse, and after that data places on the data bus. Then destination unit takes the data from the data bus, and after some time source deactivate the strobe pulse. This is the scenario in the case of source initiated, when the source initiated the transfer by activating the strobe pulse, then places the data on the data bus, then destination accept the data from the data bus, because this time is strobe pulse is activated. So, at this time the data on the data bus is valid data. Basically, strobe pulse gives the data the validity to the data. Next is scenario in the strobe control method is destination initiated. In case of destination initiated, we can see that there is the unit source unit and another unit is destination unit, and the strobe pulse is activated by the source, because the direction of the strobe is from the destination to source. Here in this scenario, the strobe pulse is activated by the destination. So, we can say that this method is called the destination initiated method, because the destination initiate the strobe pulse, or we can say that destination activates the strobe pulse. So, we can say that this method is called the destination initiated, and when the source see the strobe pulse is activated, then source unit places the data on the data bus. Then after that, destination unit takes the data from the data bus and invalidate the strobe pulse or deactivate the strobe pulse after receiving the data from the data bus. If we talk about the strobe pulse limitation, there is a one major drawback in this method, strobe control method, because the source cannot find the actual scenario, either the source or either the destination receive their data or not. We source activate the strobe pulse and places the data on the data bus, but source cannot ensure that the destination is received their data or not. For this, we can take another method, that is called handshaking method. In this method, we can the disadvantage of the strobe method is that the source unit that initiate the transfer has no way of knowing whether the destination unit has actually received the data item that was placed in the bus. The handshake method solves this problem by introducing a second control signal that provides a reply to the unit that initiates the transfer. In this case, we can see that there is a two unit, one is source unit and another is a destination unit, and we uses the three lines. First is data accepted, that is their direction from the destination to the source, and there is a data valid line and it acts as a strobe pulse lines in the previous strobe control method, and there is a data bus line, that is their direction from the source to destination. So this is the case of source initiated because the data valid line, just like a strobe line, that is activated by the source unit. So we can say that this is the source initiated method of the handshaking. In this case, the sequence of events occur in the scenario of this diagram. First, source unit place the data on the bus and data enable data valid. First, source place the data on the bus, then enable data valid. This is the first scenario. What is the second scenario? Second scenario is this: destination unit accept the data from the bus and enable data accepted. Basically, here we have three lines: data valid, data accepted, or data bus. So destination unit accept the data from the bus and enable data accepted. After that, this is the third scenario, in which after the data accepted line enabled data accepted line from the destination goes to the source unit, then source disable the data valid line, and that means this is invalidate data on the bus. Basically, if data line is valid, then we can say that data is valid on the bus. If data valid line is disabled, then we can say that data on the bus is invalidated. Then after, fourth step is this: if destination see that source disable the data valid line, then destination can disable their data accepted line and ready to accept the data. This is the initial stage of this method. Basically, process starts from here, and this is the initial state, and from the initial state is destination is ready to accept the data, and then the source places the data on the bus and data enable the data valid. And starting point of this transfer is here. This is the first point, this is the second point, this is the third point, and this is the fourth, and this is the fifth point, or we can say that this is the first point. This is the sequence of events for handshaking method of the source initiated case. And we can say source initiated because the source enable the data valid line. This is the case of this is the case of destination initiated. In this case, source unit, here is a destination unit, and there is a line called ready for data, and data valid line, and data bus. In this case, destination starts the procedure by enabling the ready for data line to the source unit, and ready for data line, when source see the ready for data line is enabled by the destination, then source can places the data on the data bus, and after that they can enable the data valid line. This is the concept of a destination initiated case, because here process ready for data line is activated by the destination. This is the sequence of events in case of handshaking method, and this method is for the destination initiated. Here in this case, we can see that the process start from this 0. We can say that this is the 0 state and this is the 1 state. The process start from this ready to accept data, enable ready for data. Destination first enable the ready for data line to the source, and when source see the enable ready for data, then source places the data on the data bus and enable data valid line. After that, destination see the data on the data bus and also see the data valid line is enabled. Then destination accept the data from the bus and disable ready for data. And when source see the ready for data is disabled, then source disable the data valid line, and this invalidate the data on the bus. This is the initial state. So we can say that there is a two sub methods in the handshaking. First one is source initiated and second one is destination initiated. Thank you.